Okay, so the first thing is we have to find the value of k. And that requires knowing that to start with, so this is part A, everyone. T of 0, when times 0, we start at 95 degrees. And then after 30 minutes, T of 30, we have 61 degrees. So we're going to use that in our equation to find the value of k. Okay, so we're going to use this second equation, which tells us that T of 30, so that means we're going to substitute 30 in for T, is 20 plus 75 e to the negative 30k. And we know that's going to be 61. You guys, so we are going to solve this equation here. We're going to set 20 plus 75 e to the negative 30k, equals 61. Okay, so first we are going to subtract 20 from both sides. And that gives us that 75 e to the negative 30k equals 61 minus 20 is 41. So now we're going to divide both sides by 75. And we get e to the negative 30k equals 41 divided by 75. So now we're going to release the exponent by taking the natural log of both sides. So log and e undo each other, and I get negative 30k is the natural log of 41 over 75. Now we're almost there for k. So now we divide by negative 30. And we get that k is natural log of 41 divided by 75 divided by negative 30. And the book is asking you what that is approximately. So using your calculator, we find out that this is 0.02013. Now to continue with the rest of the problem, we can either leave it as the exact answer or we can use the decimal. The book is suggesting we use the decimal, so that's what I'll do from here on out. Okay, so now I am going to replace the k in the original problem. So I'm going to go back here, back to the original problem, and this k will now get replaced with the value that we just figured out. So I'm going to rewrite the equation. That'll be the time of that particular cup of coffee in that particular room. So the equation becomes T of t is 20 plus 75 e to the negative 0.02013t. This is the temperature of the cup of coffee in that room at any time, starting from 0. Okay, guys, so now we're going to do the average. So in order to do the average, we have to say T average is, we're doing this from 0 to 30, so it's 1 over 30 minus 0 times the integral from 0 to 30, 20 plus 75 e to the negative 0.02013t dt. So we have to figure out that antiderivative. And then, of course, take the definite integral. Okay, so I'm going to write that again. So we have that the average temperature is 1/30 times the integral from 0 to 30, 20 plus 75 e to the negative 0.013t dt. We now have to go through and take that integral and then work it out. Okay, so I'm going to do this as two definite integrals. So this will be 1/30th. First, I'm going to do the integral from 0 to 30, 20 dt, and then plus right here, I'm going to do 1/30th, the integral from 0 to 30, 75 e to the negative 0.2013t dt. And the reason I'm doing them separately is this second integral is going to involve a u substitution. So I want to do that part separately. So I'm going to do the second one first, the u substitution. I would have to let u be negative 0.02013t, and then du is negative 0.2013 dt. So I have to divide du by negative 0.2013 to get the dt. So that's going to make this, I'll put the 75 out, 75/30ths, the integral of 1 over negative 0.2013 e to the t dt. So this antiderivative, I'm going to have 75 divided by 30 times negative 0.2013 e to the t. So that's what I'm going to have to, e to the u, you guys. This is going to be u, sorry guys, because we just did a u substitution. And that e to the u then is, so we're going to have 75 divided by 30, negative 0.2013 e to the negative 0.2013t. So it's a lot of arithmetic and a lot of algebra in that. So now we're ready to complete the problem. So this is 1/30th. The antiderivative of 20 is 20t from 0 to 30, plus, now we're doing all of this, all that we had here. So we're going to have 75 divided by 30 times negative 0.02013, right? E to the negative 0.02013t from 0 to 30. So we've got two sections now to calculate. So this first one, it's just 1/30th, 20 times 30 minus 20 times 0. The second part will be, now the second part is 75 over 30 times negative 0.2013 times e to the 30 times negative 0.2013 minus e to the 0. Okay, so now working this out, we get, so 1/30th of this, we get 20 plus 75 over 30 times negative 0.02013 times e to that minus 1 right here becomes negative 0.453324561. Now, when I work that whole thing, I get 20 plus 56.299622. So basically, it is 76.3 degrees. So the average temperature is 76.3 degrees. So I'm now going to add a third part. In part C, I'm going to say, when is the coffee temperature exactly equal to the average temperature. Okay, so now we're going to set T of t, which is 20 plus 75 e to the negative 0.02013t. We're going to set that equal to 76.3. And we want to solve for t. We want to find out at what time is it exactly equal to that average. So I'm going to go to the next page. So we're going to subtract 20. And we get 75 e to the negative 0.2013t is 20 from that is 56.3. We're going to divide by 75. And we get e to the negative 0.2013t is 56.3 over 75. Okay, so now we take the natural log of both sides, and that gives us that negative 0.02013t is the log of that quotient. So now we will divide by negative 0.2013t. And, oh, not t, we don't have t, negative 0.02013. So we get that t is approximately 14.25 minutes. So it reached that average just a little before the halfway mark.